Okay, Prasanna, I have started. Go ahead.
Yeah, I'm just disabling this menu bar here. Yeah, hi, welcome you all for the day 2 session. So, if at all, if you can just recap what we have done yesterday. So, we have walked through about what is big data and what are the key components and how much big is big data. What are the real challenges that currently we have and what could be a possible solution in order and how to handle such kind of scenarios. We will walk through in this day 2 session now, and we will see what is Hadoop and what is evolution, what is the journey in Hadoop, how it was invented, and what are the key components that comprise of Hadoop framework, and what are the other ecosystems that are part of Hadoop, which is very much essential in terms of designing an enterprise solution. So, so this is where we actually stopped yesterday. So we were discussing something about a kind of distributed processing and parallel processing using a commodity hardware. Let me start from there so that you people will catch up. So when we're discussing it something as I have discussed, so in traditional currently also we have couple of softwares which are something like heavily licensed, which are meant for distributed processing and parallel processing. There are a couple of licensed products currently available. Way back, these particular softwares are being used in many of the finance domain products because of heavy complex and at the same time they need high performance, fault tolerant. So they need many of the systems like, for example, high availability, right? Take an example about a banking solution. So in case of any banking solutions or banking domain products, they really undergo a lot of scrutiny and they undergo a lot of in terms of architectural design. It would be very complex. When I say complex, what I mean is something like the products would be uh, in order to come up or in order to design a high availability design, you would need some kind of systems which would actually provide you zero downtime. In case of downtime, failover. In case of failover, it should be the application should be highly available. When I say highly available, in terms of application instance availability, in terms of database backend instance availability, in terms of data consistency. So likewise, many factors you need to consider when we're designing a high availability to avoid any single point of failure. So when we consider all those parameters into consideration, so when we say a high availability system, so we need to handle many scenarios. So for those requirements in order to meet, so they in especially in banking finance sector, banking domain, they usually go with some already proven, already working products. Maybe you take an application cluster, maybe an application server cluster like a JBoss or WebLogic. Take about a file system like instead of local file system, they'll go with a network file system or distributed file system, and they make use of SAN storage instead of using local storage. So if they're accessing a database, they use something like a rack cluster. So likewise and forth, like will be designing a solution in a much not in a generic traditional fashion. It will be we'll be considering every point of failure. We will make it highly available. Application level, maybe operating system level, application level, database level, maybe services level. So at every each and every level where a user enters that particular section or that particular layer, we will be designing high availability. So when I compare the same thing, so now in a traditional world, we also have what I say is something like distributed processing and everything, but those products are very much complex in design. At the same time, they are very costly. And in traditionally, they use those softwares especially to run on some a high-end hardware. Maybe we can say as something like a high-end servers, because usually they need some kind of high processing compute systems to handle such kind of heavy payloads. Now, what Google has resolved is something like they have come up with an algorithm called MapReduce program, which is something like they will use some kind of a divide and conquer rule. Very simple. They would what they do is they will divides the task into small parts, something like maps or tasks. So those tasks would be assigned to whichever system is part of the particular cluster. That particular mapper job would run on something like it is doesn't need not to be a high-end hardware. It can also be formed using regular commodity hardware. When I say commodity hardware, it can be a high-end desktop. Need not to be high-end desktop, it can be a desktop. Or what I mean is something like if you want to come up with a good design, so generally they use a decent hardware, maybe having a 10 GB RAM or with some i5 processor and everything. But only catch is it need not to be a high-end hardware, high-end server. So with basic configuration, like if all the systems need to be connected to a switch, it should be part of a single LAN or a subnet, and then we will be using all those instances. There is no need for us to do a great configuration with very minimal set of configurations, copying a Hadoop framework. There is something kind of set of instruction. We'll be discussing those things in a very deep dive in following sessions. But to to start the journey, just imagine that it doesn't require a seamless or a very complex installation. It is very simple. Just copy those binaries and do some configurations. Will make your Hadoop cluster. From there on, so what Google has resolved is something like they have divided into small tasks, and those tasks are actually running on this commodity hardware. Once this task is done, and that particular thing would be handed over back to there will be another piece of hardware it called as reducer. The reducer's job is something like whatever parallelly processed outputs that we have received from all the mappers, that particular output will be again consolidated back by a reducer, a single reducer or a multiple reducer, and that particular job will again run some piece of code, and eventually you will get an output. So all the interactions between mappers and how are we going to divide that particular task, and the data that is currently residing on storage, Everything is fully managed, everything is fully tolerant, everything is highly available architecture with very, very minimal less efforts. What Google has resolved is only they have told that they have innovated the idea of creating an algorithm called MapReduce. Now really the journey started. So after Google has innovated this and Apache Foundation open source community, actually what they have done is they have actually come up with a decent architecture and they have named it as Hadoop. So Hadoop is something like it is designed to be robust in any of big data applications. So we will use this particular framework because for many various reasons. These are the um so what it generally says by definition is something like Apache Foundation Library is a framework that allows the distributed processing of large data sets across clusters of computer using simple programming models. When I say simple programming models, what I simple programming model here means, I don't know how many people who are coming from an OOPS background, maybe from Java .NET. So this in OOPS concepts, there is a concept called as collections. So whenever we want to deal with some collection of items, so in either Java or .NET or any OOPS supported programming languages, collections is a very key part. In collections, maybe they call it as LLAs, strings, arrays, maps, hash map, hash table. So there is something like there are very possible ways or scenarios in which how do we use or iterate through your collection of items. So there are many different designs or different attributes, different types of categories of collections available. Out among them, map is one collection item. What is the beauty of map is something like we will be storing the information in the form of a key and a value pair. When I say key and a value pair, key should be unique and you will associate a value for each key item. We will iterate through these similar map objects and we will eventually come up with a paradigm around this usage of map object. So Hadoop, as we see just seen, simple programming means with just having an idea about how do we manage map objects. The entire concept goes around that particular same concept. How are we storing those maps? How do we store those values around it? But what it is actually, it is designed for scale up from single server to thousands of machines, each offering local computation and storage. Rather than relying on hardware to deliver high availability, the library itself is designed to detect, handle failures at application layer. So delivering a high availability service on top of cluster of computers, each of which may prone to be failures. So what it actually means is, when I before starting the framework, so the traditional distributed processing, if at all if you want to achieve those high availability architecture, we need a kind of a licensed product. So what is the difference between that product and Hadoop is almost more or less same. Here, main biggest advantage, we can run this particular thing with very minimal configuration and we can create a Hadoop cluster. Forming a cluster is very simple with very less configuration. Second thing is, so if at all if we want to expand, maybe scale up and scale down, the number of instances which are forming the Hadoop cluster, it is very dynamic in nature. All that we need to do is we need to just invoke this same configuration with very less attributes. We can scale up and scale down. And the biggest advantage is something like, take an example, typically you're forming an Hadoop cluster, having it as a matter of best practices, we'll take all identical systems. Per se, you have a quad-core processor system having 8 GB of RAM with some 20 GB of storage in each computer. So when we are forming a cluster, so let us consider in a traditional world, if at all if we want to use storage in another computer which is actually available within the same LAN, you need some kind of a file system, right? A kind of network file system. So, and also that particular file system should be able to access not only the data, sometimes if at all, in case of any failure happens to your node, your data need to be replicated. Data need to be highly available, or we can say fault tolerant. So to achieve those things, you need a special file system, right? So even that particular thing concept is also part of the Hadoop framework. So the Hadoop framework is takes care about fault tolerance and in detecting of failures, everything. So we will just walk through how Hadoop does it and what are the key components that would make comprise of Hadoop framework in next coming slides. So what are the key features? What would say is something like Hadoop, as we said, that it is mainly meant for processing huge amounts of data, any kind of data, maybe you can say unstructured data. So computing power. So distributed computing model quickly processes a big data. The more computing nodes you use, more processing power we will be getting. Very simple. So if you want to process a huge chunk of unstructured data, we would need more compute power. When I say more compute power, you need more systems, more storage. So with very minimal configuration, we can form a Hadoop cluster or we can scale up. Flexibility. Unlike traditional relational databases, you don't have to pre-process data before storing it. You can store as much of data as you want, which includes unstructured data like text, images, and videos. When I say flexibility, here now take a comparison of something like we are having an RDBMS solution which can accept or data can grow till 2 TB. So whenever we want to store the data, we need to store the data in a specific format. That's where we call it that as a structured data. We'll be storing the information in the form of tables, rows, and columns. But whereas unstructured data, there will be no specific schema, there is no specific format. So only that we can come to a conclusion like the data can be anywhere. There is no fixed schema. Take a CSV formatted output. Each line of item may contain whatever the data that you need, but it will be not of fixed length. For example, the data may be available in the first few words or last few words. You never know. You need to understand the pattern of data. Accordingly, we'll come up with your own design. But when you compare with an RDBMS solution, definitely yes, it is a responsibility of whoever is actually storing the data. They need to follow a kind of a specific schema, and they need to insert the data in the form of rows and columns in a specific table. No matter what, whoever actually retrieves the data will follow some kind of a basic design principles, like they'll query using a language called SQL. So that would maintain all those data consistency techniques, and every database actually follows some ACID properties that would actually give you all sorts of data consistencies and related problems. So whoever retrieves the data will get the same data. It's something like if you retrieve at T1 and if you retrieve at T2 timestamp depending upon the data that is stored inside the RDBMS solution. If it is a committed data, you will get the same data across because it maintains data consistency standards. Now, when we say flexibility here, it can be streaming data, it can be a text data, it can be a raw data. When we say classify the data as unstructured data, the data will keep on growing in nature, and that doesn't need any kind of pre-processing if it is actually getting stored onto a Hadoop file system. So we'll slowly talk about a file system also in the next coming slides. But what I would like to say is, with the use of this common commodity hardware, we are actually summing up or making use of storage that is associated to each commodity hardware. When I say commodity hardware, we have whatever the local hard disk that we have, those storage devices form a network file system. They call it as in Hadoop jargons. They call it as Hadoop Distributed File System (HDFS). That in turn is maintains the storage. That maintains the kind of an pool of storage in which whenever we want to process any unstructured data, it is up to the responsibility. We need to store that information onto this HDFS file system. There are a couple of commands we'll be discussing when we're actually walking through the demo. But for timing, you just understand we will be using those storage devices associated to those commodity hardware. We will create such kind of a file system, network file system or a distributed file system. But in a traditional world, if you want to come up with the same thing, you need a kind of a storage area network. You need to have a heavy infrastructure for that. But with very simple configuration, with simple installation, we are actually forming that part of a distributed file system. Now comes to fault tolerant. When I say fault tolerant, it can be data, data replication, at the same time instance availability. So whenever whatever data that actually we store onto this HDFS file system, the data would be replicated or highly available in nature. Every bit of data that we actually store, the data gets replicated in couple of other nodes. So in case of any node failure, you can easily sustain because the data is highly available spread across in other available nodes. So as Hadoop actually comes with an approach paradigm called distributed processing, so that takes care of instance availability and your data availability. Why it is low cost? First, the framework itself is coming up from an open source community, whereas the license cost is very, very low, and it makes use of commodity hardware. So there is no special recommendations from a framework. It just can be run on a basic commodity hardware, and it does not need any kind of a storage special infrastructure like SAN or something. With whatever local hard disk that actually it comes along with commodity hardware, using those storage devices itself, we can come up with a file system, distributed file system, by installing Hadoop framework on top of it. Now scalability. Scalability, when we talk about it, how we will design a, let us consider our design is something like we want to process 1 TB of data in some specific time frame. Let us consider 1 TB for using a 10 node cluster. It is actually resolving you something like it will giving you data within 10 minutes. Now if at all if you want to reduce the time, you need to increase your CPU, or if at all if you want to process maybe a 10 TB of data, you need higher CPU, right? So if at all if you want to grow, it is very simple. It is not most likely like if at all if you want to take when you comparison with any application cluster, it does not need any great setup. with very, very minimal set of configurations, we can increase the size of Hadoop cluster. That's where we got it as scalability. It can easily grow. So this is what actually we're gonna cover for this entire uh, day today. So Hadoop ecosystem. Now currently we have two versions of Hadoop currently available in the market. One is 1.0 and another is 2.0. We will be covering both the concepts, but you need to understand some basic core concepts. So we will go something in deep in both the fronts. First you'll understand 1.0 and then we will discuss about what recent enhancements that was actually done to the Hadoop framework and 2.0 framework. So hope if at all if everybody can see my screen, there is something called as a MapReduce framework which is highlighted in gray color. There's something called as distributed file system. So whatever unstructured data that actually we would like to process it, that particular data will resides on this HDFS file system, which is nothing but Hadoop for distributed file system. Now, what this ecosystem talks about is, sorry. So there are different products which are comprises of your not Hadoop. It's something like as part of your big data processing, you need different products as such for a specific purpose. Hive is something it is very much essential whenever we actually want to design a data warehousing solution. So Hive is one such open source software which actually provides whenever you want to design a data warehousing like kind of solution. Pig and Latin. So as I said, Hadoop also supports scripting languages. It's one of the Pig is one kind of other scripting language. It is mainly generally all the network administrators or OS administrators who are actually good at bash scripting. Pig is also a similar kind of a script. Using that particular script, you can it would eventually generate MapReduce program at the backend, and with that, they actually process some kind of big data. What is Mahout? Mahout is something like machine learning. Machine learning, I don't know how I would like to convey. Maybe I think many people would have actually gone to any e-commerce sites like Amazon, Flipkart, or Jabong or something. So whenever we search for a particular item, automatically that site would give you a responsive. It comes with some kind of an intelligence by default. Whenever we search for an item, maybe just do a very dynamic thing. Just go to Amazon. So just go to Amazon and say watches. So I selected this particular watch. So I selected this watch. Can you guys see here? Frequently brought together. Customers who brought this item also bought this. Sounds related to. So it give you all this kind of analysis, right? There's something called as predictive analysis. So how Amazon has actually got these items? What is this beauty here is this is undergo something kind of predictive analysis at the backend, and it gives the kind of a return the query. This is all something called as machine learning. So when I say machine learning here, this particular input is already given to the system. So whenever we're actually searching for a particular item, that particular item is already being queried at the backend, and the particular output actually gives you this. Everything is dynamic here. Everything is dynamic. So it is not because only we have selected this particular watch you got this. If you select any other watch also you get the same similar items. Okay. I selected this watch. I got some different output. Okay, I selected this particular bracelet, I got some other different things. So it is not pre-programmed. The data that you are getting is all dynamic. So how is this particular dynamic, how this dynamism is coming? This is a raw something concepts called as Mahout. It's a it's a end-to-end different discussion altogether. But what I would like to say is something like there is a concept called machine learning. It actually comes with a kind of a concept called as a predictive analysis. So we can even design such kind of solutions. You just see we are actually querying something on, like, just take Amazon as a e-commerce customer. You just imagine how much the size of the data that actually we're querying it on. So just imagine that you people know how Amazon is big. So we are querying something on the warehouse that actually which comprises of some millions, some trillions of products that are currently available, but still with one search you're able to get the similar items or whatever the customers. This is all dynamic, how this everything is properly organized. So this also needs some kind of big data related networks. Now currently all the e-commerce big players are implementing all these Mahout predictive analysis plugins at the backend, which would eventually give you those kind of extra facilities that are provided to the customers in order to give more comfort in terms of buying the products, which will really enable them to buy product with very less effort. That's what actually any e-commerce website would actually have an objective. So likewise, there are tons, thousands of products that are getting emerged daily. So I would say, like, you need to be very adaptive in nature, flexible in nature, and actually learning new tools and technologies that are coming under big data related community. So Apache Foundation has some thousands of products that are currently being emerging daily. So it comes with a very huge set of file system actually. These are all products only. Whatever that you're seeing is all products. Maybe I'll just take this as an example. Everybody can see, right? There is something called as Ambari, there is something called as Scoop, Flume, Zookeeper, File System, Yarn, OZ, Pig, Mahout, R connectors, Hive. This is not simple completed. You have some other products also. On a very high level, this is something at very small thing. Okay, very, very small thing. Maybe this is a very good example people actually giving you. So there are different products which are meant for specific purpose out there. Ambari is mainly meant for uh, management and monitoring. Maybe I'll just copy this image. So what I mean is something like it actually it is growing in nature currently. There are several thousands of products that are being emerged daily. Out among them, first you should understand Hadoop framework in a very something like you need to imagine how Hadoop is actually being used in terms of processing unstructured data. From there on, you need to expand your limits in learning basic products. I would not say that it's something like when you learn Hadoop, it's end of big data. No, it's not like that. Even for big data as a domain, so you need to learn at least minimum not less than some kind of products like, for example, this is a highly available system, okay? This is what where an enterprise would look at. So you need management and monitoring. Something like whenever we are submitting a kind of a Hadoop job, you need to understand whether the job is successful or not, which nodes are actually working out, how nodes are actually what node is actually at performing at each level, which node is performing well, which node performance is low. Are you having any kind of a space issues or storage issues? So in case of node failure, what is actually happening? Is your data is actually consistent or not? So all these things actually comes under management and monitoring. Scripting we have already discussed. Machine learning is all about predictive analysis. Now query. Hive is something like another wrapper ecosystem where it will give you support like if at all if you just give a command as similar as your SQL command. Sorry. Sorry guys, I'm back. Excuse me. So So we can give input as a SQL like a small string that would eventually get converted into a MapReduce job, and that would get submitted, and that would actually process your big data as well. So that ecosystem is nothing but a Hive, and you people would have heard about NoSQL databases, right? So NoSQL databases are something like they will don't have any kind of a specific schema. The data can be organized in a columnar approach. Getting the data from NoSQL is actually depending upon the context how we store the data. So we can store, like for example, take something like maybe a social networking site where the data would grow seamlessly, but there should be some kind of a specific format, right? How do we store the data? That particular data would be stored definitely on a NoSQL like environment where you never know it's something like there will be no specific schema or a fixed schema. Today we have about 10 columns. Tomorrow you may have more than another column getting added, or there will be instances where you may not store some other information. Take a typical example using a Facebook as a social networking site. So in many of your profiles, you say that you don't like a specific, for example, take any tweak, you don't like it, but whenever you are liking a specific a thread, so every thread would actually maintain some specific attributes like who is accessing on whose page, permissions, and all those things. At the same time, whatever profile that actually you maintain, you add few attributes, some add some more attributes, some add some different attributes on than others. So all this something like there will be no fixed schema as such. So every profile actually is stored in a kind of a concept called as an object, and every object can comprise of different attributes. So if you want such kind of an environment where you would like to come about, so those things will categorize to be storing it on NoSQL like environment where we'll be using HBase. There will be some concept called as Zookeeper and Woozy. Zookeeper is basically meant for workflow, what we are supposed to do when we're actually processing some specific set of data sets. So what is the workflow? What is the stepwise sequence of execution that need to be done? So when we're processing some huge data, So we need some kind of a workflow, right? First, we need to load the data onto the HTTPS file system. Then we will cleanse the data. We will sort the data for. There will be some kind of best practices before we're doing it. So some kind of pre-processing that we do before we actually run the actual MapReduce job. Yesterday, remember, right? We actually did something like we discussed like we need some kind of a testing expertise also before we run. So those steps we'll be doing it before we actually submit the actual job. So before to that, we'll actually work on the some kind of a steps. Zookeeper and this Uzi framework actually is mainly essential in actually doing those things. So MapReduce, that is a heart. So that will actually take care of all sorts of distributed and parallel processing. And distributed storage, HDFS is the storage file system where you actually the real unstructured data actually gets stored. And whenever you want to process anything using Hadoop as a technique, then we need to store the data onto HDFS file system. Then last comes the scoop. So what is scoop is something like SQL for NoSQL. It is something like SQL operations for this. What I say is open source. So what this scoop actually helps us in doing is, so if we have a requirement as such, like we will process this unstructured data, and after processing this unstructured data, whatever output that we get, we want to store it onto a kind of a traditional HDFS, a traditional database, something like a real-time RDMS solution, maybe an SQL or an Oracle. Let us consider we are processing something like a countrywide census, and after we process something, we'll be getting some kind of an output, a kind of a statistics. So we want to store that kind of output onto an RDBMS solution such that after we store the data onto the RDBMS, then we would like to use some kind of a reporting solution which would actually eventually gather those information from this RDBMS and generate some kind of graphs or a UI or a report. That is how typically the flow goes. So you will process 1 TB of data, you get some result, that result gets stored onto a kind of a traditional RDBMS. From there, your reporting or a dashboarding tool, maybe a Tableau or a ClickView or a customizable view that gets deployed onto a kind of a simple enterprise solution, crystal reports and all. Those will actually access your traditional RDBMS and generates the report. This is how typically your life cycle actually goes, with some of very important components that comprise of Hadoop file ecosystem. So I would actually stop here because I don't want to confuse if I start Hadoop file system and the components that definitely make you confuse. I would take to kind of a logical break. So this is all about the different uh, products that are part of Hadoop ecosystem. Each product is comprises and it's basically unique in nature and is mainly used in a specific context. So I would like to take stop here for today. So any questions? Let's have the floor is open. You can start discussing today. Any questions so far? So there's a question coming up from participant called Shobha. Let me bring it onto the deck. So can I say with the evaluation of Hadoop, we don't have ETL system and data warehousing? No, your understanding is not right. It's not evaluation of Hadoop is actually no, we don't have ETL system. So we are actually processing unstructured data. Okay, that is where you actually need to focus on. So when you say unstructured data, that data can be of any size. Let us consider 1 PB. So just imagine like a system where Informatica system which actually need take a traditional Informatica system. Informatica is mainly meant for doing ETL kind of job where the data size cannot be exceeding more than some 1 TB. If the data size is more, eventually your Informatica job will fail. Say that the data is more huge, or it says that timeout. So here what actually we are doing is we are actually processing this kind of unstructured data. After this, when we process this unstructured data, we get some kind of meaningful data in some specific format. Okay, it will be something, it will be generating some structured data only. Otherwise it will be useless, right? We'll process unstructured data and then we get structured data, and this data we will feed this data to any kind of RDBMS solution, and from here on even it is up to you. If at all if you want to process something using an ETL system and then you again come up with some kind of a statistics or kind of reports, it's all your call. So where do we use this ETL kind of systems? When we have a data warehouse, right? Let us consider this is a data warehousing system, DW warehouse, and then you attach your regular ETL system to this data warehouse and then you take the reports. Hope this answers, right? Shobha, are you clear? Maybe I hope this is answer. Yeah, thank you. So next comes the other concept. What format of data that gets stored in HDFS file system? What format the data is stored is here. It is something like maybe if at all if you're understanding well, every operating system actually make uses of a file system. Per se, take Windows, it uses some kind of a FAT32. Your NTFS, take Linux, it use ext3. So what is this all about? A file system means how operating system is organizing your data. It is not like converting of data, it is organizing of data. How an operating system will organize your data and store your data. Okay, so each file system has its own rules and regulations which actually helps in an operating system to organize and store the data. Now what format the data is getting stored is the same what actually it does, but HDFS by nature it's a distributed file system, right? It's a distributed file system as you're talking about. So take an example of a typical example where we have said that we have community hardware like C1, C2, maybe we could call it as nodes, N1, N2, N3, N4 and N5. Each system has a 10 GB of 10 TB of storage. So that means we have 5 nodes, 5 into 10, 50 TB, right? So when we form a Hadoop cluster, there will be a HDFS partition of size 50 TB gets generated. When we just say a file.txt of size 1 TB, this file is splitted across and stored onto this HDFS file system. We are not sure what, let us consider this entire file.txt got splitted into some 100 small, there is something like you need to understand. We are very too early to discuss now, but I'm just saying this particular file got split into small pieces called as blocks. Okay, 1 TB is actually split into 100 blocks, and this particular 100 blocks are spread across in this 50 TB HDFS partition. This is how the data gets splitted across. It is not like there is a specific format to it. There is another hope. Kiran, I think you are very too early. Yeah, it is serial or relational. It will be serial. It is doesn't like serial or relational. The data gets divided basing on some kind of a algorithm that actually designed by a MapReduce framework that would take care of how to divide, how what is a fraction, who would decide what is a block size, everything that we'll be discussing in the next following sessions. That is completely automatic, that is completely taken away by a MapReduce paradigm, and the Hadoop has its own intelligence in dividing it. Who would divide, who would give the task to a mapper, everything is completely fully managed by the Hadoop system itself. You cannot say serial or relation, it is dynamic in nature. Let us consider to the other question. I'll come back to Sandeep, just give me some more time. Are all these, maybe I don't know whether, okay. Are all these tools required to be mastered, and if they are covered in the course or not? Very interesting question. Very interesting question. So definitely yes. We will never, our time is not sufficient if at all if we want to cover all ecosystem products. Maybe it's time to again recap. I don't know, like I'll just check with Manoj, where did we publish the topics? So these are the topics actually we're covering here. We'll be covering pig, we'll be covering hive, Uzi. So these three things are very much essential when we're actually designing any kind of big data components. So as part of the course is concerned, so we'll be covering Hadoop, hive, pig, and Uzi, scoop. So if at all if you want to design any kind of unstructured data, if you want to process it, if you know these concepts, you can start off. This particular content is designed in perception to at least give a basic fair idea on what is big data domain is all about, and what are the mostly frequently used products, and how we actually design a enterprise solution using Hadoop ecosystem products. So if at all if you want more ecosystem products, definitely yes, we will be covering in the next following batches. For time being, we will actually starting with this particular entry level course. We don't want to confuse, at the same time we don't want to make sure that the basic core building blocks are clear, and then we can build on top of it. What is a prerequisite for the course? Maybe this is an interesting question. So what is prerequisite for this course? First, I would say clear mind, enthusiastic to learn new things, and then I would say blindly accept what I'm saying. I'm just kidding. So prerequisite is something like you need to understand the concept in some answer, where you need to understand something like traditional, what is the potential challenges that actually we have with RDBMS when we are dealing with huge data. huge data. When I say huge data, it can be ranging of either 1 GB to 1 ZB or to PB. Like it can go to 1 PB, petabytes, and to 1 ZB, zettabytes. So you need to just open up your mind and you should think big. Big data is all about thinking big only. But you need to understand something like whatever that you are currently being taught, that product has its capability to process such kind of a huge payload. It's all that you need to have a high processing compute system which would eventually helpful in actually resolving it. But whatever the code that you write for processing small data or large data, whatever data, it's all about, it's not the code. It's not like you will write, for example, if you are processing 1 PB of data, you will write some 1,000 lines of code. If at all, if you want to process 1 GB of data, you write some 1,000 into some another 1,000 lines of code. It's not like that. Whatever code that we have written, it is not something like depending upon the size of the data that you write more complex logic. It's not like that. The logic remains the same, but whatever data you would like to process, the system will capable of handling it. So prerequisite is something like very simple. You need to at least have any knowledge on supported frameworks that are being supported by Hadoop. So I think maybe I missed yesterday. I haven't given you that answer. Maybe today I'll just give you that. Hadoop supported technologies, Java.NET. I think there will be some kind of a wiki link actually. Yeah, can you see this? So this Hadoop primarily actually uses of, it's something like it is actually basically developed on backend is Java technology, because it makes uses of um, everything whatever that we write, that is eventually gets converted into a MapReduce job. The entire Hadoop architecture is actually designed such a way that the entire backend code is Java, and it actually supports some kind of a API. That particular API supports different languages. These are the other different languages. Okay, and something like there is some concept it talks about technologies. Why am I not getting? I'm not sure. So these are all. This is the basic link. I would be giving those useful links in the next following slides. Maybe I'll just request you people to just go through those things so that we will actually go ahead and uh, it helps you for your self-learning first thing, and second thing is I'll make sure these particular links are published so that you people can actually go through these links before we actually attending the session. So Hadoop, this is the main basic link where we actually talk about it. Maybe in the next coming slides, next coming sessions, we'll be sharing all these important links that we can learn. I think I have already documented it in the way back, but those links are actually taught in the last. Yeah, I'll make sure those links are published in the next coming slides. Okay, so don't worry. So those links can be published. I'll give you as information as possible. So this is the main Apache Foundation Hadoop documentation link. From this link only, actually, we'll talk about the products, ecosystems are currently available that are being supported in turn by Hadoop, and at the same time, so how are you going to do the installation, everything? And as part of this week calendar, what I would say is maybe till 8th we'll be covering more towards the concepts, core concepts that are part of the Hadoop framework and design. From next week onwards, we'll be discussing more on installation, single node installation, and then followed by running examples, designing Hadoop programs, developing MapReduce programs, and handling different data sets. After that, we'll be discussing more towards what are the other ecosystem products that comprise of big data. Using those technologies, we'll be developing some kind of other demos, followed by we'll be designing a kind of a high availability architecture, and we will be covering all those real-time use cases. This is how typically it actually goes. So we'll be discussing something like MapReduce 1 versus Hadoop 1 versus Hadoop 2, and then we'll discuss about different advanced concepts. We'll walk through some demos, and then we actually uses all these other ecosystem products. As I told, we'll be using this talent also at the end of the each session. Whatever we have done using MapReduce program, we'll be doing the same thing using a tool called talent. We'll be demonstrating that particular part also. So that's all about it for today. We are already ahead of time, 9 minutes over. So any other further questions that actually people have, so that we'll try to answer it before we break for today. So we have about how many people we have? We have 9 people coming up. Hope I have answered all your queries. If at all, if any, I missed out any question, please bring up onto the board. We'll try to answer it. If everything is clear, then probably we'll break for today. Does big data has competitors? Okay. I'm very sorry. Did I miss your question? When I say competitors, what I mean by competitors here is it is not like competitors that we have. So so this big data is a basically, maybe I don't know whether you are getting confused. If you just use big data, why Hadoop is coming? It is not like Hadoop is different, big data is different. Big data is a domain and Hadoop is a technology. Okay, what is the other substituted technologies that actually comprise of big data? That's a different question altogether. If at all, if you want to process big data, then Hadoop is the only one technology currently available. So what are the products? Okay, big data products. Okay. So the products, depending upon the each vendor, they have tons and tons of products that are emerging day by day. Okay. So each company has their own product. Okay. Every company. Now, every traditional RDBMS vendor is now supporting big data. So what I mean is they have connectors to access the data from a HDFS file system and do some kind of a computation logic and then move it on to an RDBMS solution so that you are, it's end of the day, what is the purpose of using big data is something like you're processing big data and converting of or whatever uh, processing structured data, getting some structured data out of it, and then the data is getting fed onto your traditional RDBMS solution. From there on, the traditional system goes as like whatever we are doing so far now. Currently, the same thing applies. Maybe you can attach to an ETL system. Maybe you can attach to a reporting framework. It's all about it. End of the day. But the only problem here is the traditional RDBMS solutions does not support heavy payloads. The data cannot, the file system cannot grow in size because they have their own limitations in actually organizing the data. For that reason, they need to have any connector that would actually allows them to connect to HDFS or Hadoop ecosystem products. Now, every product vendor which is actually massive in scale, who have their own databases, now they're actually supporting big data. They are supporting Hadoop and Hadoop ecosystem products so that they can access those things. These are all other tools and technologies and products that are being available in the market which are actually supporting big data related ecosystem products. Hope this point is clear, right? There is no competitors as such. There are specific products, product chain, but there is no alternative to Hadoop. Hadoop is the only one technology. And under Hadoop as an ecosystem, you have several products that we have seen it in the next before slides. These are some products that I can give it in hand, but this is not the only final list. There are many, and they are growing, emerging like anything. Every day, maybe I would say every 6 months, there is a new product coming up in the wiki page. Maybe just you need to walk through this Hadoop wiki. This Hadoop wiki actually gives you all products. And as I said, you need to understand Hadoop is actually coming from Apache community, and it's something like Unix is basically an open source, whereas Red Hat is RHEL version is not licensed, it's not freeware, right? So Hadoop different distributions, okay? Distributions here when I talk different flavors of Hadoop. Okay, different flavors of Hadoop means all these particular vendors took the base release from Apache Foundation, and each vendor has added some kind of new intelligence to the Hadoop, and they're actually coming up. These are all different distributions currently available in the market. Every vendor is actually doing some kind of adding few parameters, few options, few new features, everything. Out among them, Hortonworks is one big vendor. There is a vendor called Cloudera. This is a big vendor. These two distributions are currently very well widely being implemented at enterprise levels because these two communities give production support in case of you are implementing a solution on a production like systems and handling heavy payloads. These two communities, Cloudera distributions and Hortonworks distributions, are all the only two available vendors currently in the market which are proven and they are giving production support. In case of any issues, in case of patches, everything, these people are actually owning that particular distribution support. But whereas Apache Foundation is not offering any sort of support for their hardwares or issues. Getting? So Cloudera and Hortonworks, these two are the distributions currently available in the market, which are very, very powerful, and they are ruling the market as of now. 150% is being handled by Cloudera, and another 50 is actually handled by Hortonworks, close to. So hope you got it right. It's something like Hadoop is an open source, but these vendors have customized the existing release and they have created their own products on top of it, and those products are being supported by them. As they are giving production support, because many enterprises needs production support, without that nobody is actually qualified to use it on their production systems. We will discuss something in detail in the next coming sessions. Hope you all had a great session today. So any further questions before we wind up? Are we good today? Looks like nobody actually coming up any questions. So with that said, probably we'll wind up for today. We'll touch base tomorrow. Thank you all once again for joining, and I wish you a great day. Do we have class tomorrow? Yes, we have a class. We actually running the regular class from today. Not even today, from yesterday. So the sessions will keep on continuing from tomorrow. So it's basically a 5-day sessions, 5-day a week. So we'll go over from Monday to Friday. So hope you all enjoying it. I tried my best to make it more interactive. So from tomorrow we'll be discussing more towards what is MapReduce framework, how do we create MapReduce programs, and how to do some basic installations, and how are we doing, how to process some kind of unstructured data and all. So let's connect tomorrow. Have a great day, and maybe good night for the people who are joining from US community. I have a quick question. How many actually coming up from non-US location? Is everybody coming from US, or is anybody who's actually joining from India other than US? Sandeep from USA. Maybe you can just give me some kind of which part of USA. Maria, yeah, you can access the PPT. Probably you can just contact Manoj. You should be able to get yourself. Phoenix, we have 2 associates. Salt Lake, Sandeep. How about other people? I got 4 people. I think Sridevi and other people. It's okay. Anyway, I believe like everybody is coming from USA. I understand. From Canada. That's great. And maybe last but not the least, is my English is fine, or you see any issues with my English, or is my accent is okay? Yeah, that's good. Hope my accent is neutral. Okay, thank you. So Sridevi, you're from India or you're from US? Okay, perfect. So looks like nobody's actually joining from India except me. That's fine. So then I would say a very maybe good night for you all. Let's connect tomorrow. Thank you. Thank you all.